everyone. Welcome to Reinforce. I'm Tim O'Brien. I'm a solution architect with AWS, and I'm joined by my customer today, Akansh Grover, who is the security lead at Meta, formerly known as Facebook. We're here to talk to you about Secure by Design. Kind of a packed agenda. What we're going to do is start with what is Secure by Design, give you just a nice metaphor for that. We're going to go through a quick 4 slides on what the approach is, and then Akansh is going to dive into all the rest of the detail around what those 4 different steps in the approach are. What is Secure by Design? I think a lot of us in the security world have talked about which is a better approach, the fish or the lobster. The lobster has the shell, you harden your security on the outside, and I think we all know that that's not a great approach because if you penetrate that outside exterior, you now have a breach, and we don't want that. So what we do is we scatter that security across the entire structure, more like a fish would be, where the bone is everywhere. But Meta has taken that to a different step, and we have a metaphor for you, and that is baking. If you cook a cake, you don't just put the sugar in one spot or just put it around the exterior. You mix it into everything. And that's a perfect metaphor for what Secure by Design is all about. We have a 4-step approach here. And that approach, because it involves baking that cake, everything involved with that approach is going to talk about security throughout the entire process. First step, we're going to establish requirements, deeper than what you would just do for software, much deeper than that. We're going to add a lot of things around security into that whole process. We're going to build out a nice secure environment with good guardrails. We're going to make those guardrails stand the test of time by building in an enforcement mechanism, and then finally we'll do validation checks. First thing, just like you do today when you build software, you're going to sit down and think about all your requirements. But it's more complicated than that because what you have to do is figure out what is AWS going to do for you with the shared responsibility model. And that's going to help drive different things that you're going to do for your security beyond what AWS will provide to you. We'll look at all the preventative, detective controls that you might put in, plus responsive controls if one of those happens to fail or you get triggered. And then, of course, Akansh is going to talk in detail about policies. Second phase, you want to build that environment. Now you understand what you want to build, you're going to actually go out and build it, and you're going to talk a lot about what data is involved. Are you going to do data at rest? How are you going to handle this data in transit? Are you going to encrypt? How are you going to handle all the privacy and compliance issues around data? You're going to decide what resources you use and how you're going to provide security over all those resources. You're going to do this by templatizing things so that you can repeat it over and over again in a very secure manner. And then finally, the big one, and Akansh will talk about this in some depth, is managing SSH. Cloud SSH can be a very powerful tool. It can also be a huge weakness if you don't handle it properly. Phase 3, we're going to put the preventative controls in place. We're going to provision those accounts with the guardrails already built in. We're going to use lots of standard templates. Things like AMIs will be built in a standard mechanism. We're going to use service control policies to help make sure that those guardrails remain in place throughout the entire life cycle of this workload. We're going to do static code analysis. It's important. We want to make sure that not only is the environment that we're running on secure, but we make sure that the code's actually secure as well. We're going to look at guard duty to make sure that we take care of any kind of notifications we might have. And because it's Meta, they do all kinds of infra as code on-prem as well as in the cloud. Meta makes sure that they use Chef for all the deployment. And the fourth thing, validation checks. We want to make sure we now have detective controls in place if things get triggered. AWS health notifications are involved in that. We're going to take a look at all of our inventory and make sure that we don't have drift away from what the standard is. And we want to do audit logging so that we can actually trace the kinds of things that might go wrong. And now it's my great pleasure to bring up Akansh Grover, Security Lead for Meta.
Thank you, Tim. So before we dive deeper into Meta's cloud story, let's discuss what's Meta. So Meta's mission is to connect the world, give power to users to stay connected with family, stay connected with friends, build social experiences using our apps and services. Meta operates some of the most downloaded apps on Apple App Store, Google Play Store. They include Facebook Blue app, Instagram, Messenger, WhatsApp. We also have our hardware division building virtual reality headsets called Oculus. As of Q1 2022, we have 3.6 billion users using our services, using our applications. To provide some context, I think the total population of the world is 7.7 billion, so we're almost halfway there. We have data centers all around the world to support our growth, to support our apps. They provide an easy way to make our applications reliable, to scale well for our users, to support our mission. Our data centers are some of the most sustainable data centers in the world. We actually end up adding energy to the local grid most of the time. That's about Meta. Let's discuss who am I, what's my role, what's my team. So I'm a security engineer. I lead a team called Cloud Foundation Platform. Cloud Foundation Platform is a production engineering team. Production engineering in Meta is a hybrid between software and system engineering. We are the people who make sure our apps our services are reliable. If a developer works on a feature, we are the people who make sure our user base can use that feature. Production engineering in Meta was created to champion things like reliability, scalability, even security within our product space. Security engineers, like myself, are embedded within the team. Security engineers in Meta are responsible to make sure our users using our services have a secure way to interact with their friends, family, build social interactions. We provide the security layer for all of our apps. Security engineering is a very, very important part of our culture, and we take it very seriously. So this is probably a question you have. Why is Meta in cloud? I just said we have amazing internal infrastructure to manage our application, to support our applications, to support our scale, to support our users. Why are we using AWS? Why are we investing so much energy in cloud? Well, there are a lot of different problems we want to solve using AWS, but most of them can be related to these 4 pillars. The first one is latency or speed. So some of the applications are very sensitive. A longer round trip time between the application server and the end user can kill your service. So we have a lot of data centers all around the world, but we don't have them in every country, every region of the world. AWS solves that gap for us. Compliance. We operate in a lot of countries all around the world. Every country has different compliance policies related to user data, related to their population. For example, payment data. Some of the countries don't want payment data to go outside the geographical location of the country. Like I said earlier, we have a lot of data centers, but we don't have them in every country. AWS can sometimes fill that gap too. Specialized capabilities. So our infrastructure is very optimized for our applications, for our scale, but sometimes people want to experiment with different kind of architectures, different kind of services. AWS solves that problem for us. AWS has more than 200, I guess 300 at this point, services in their infra, and our developers can leverage those, create new types of architecture, experiment with new types of applications. Faster experimentation. We have an army of research scientists building machine learning models to run our applications to support our users. Sometimes we need extra GPU power to run those models. AWS fills that gap too. So one of the main goals for my team is to integrate AWS technologies with our internal Meta technologies. We at Meta have solved a lot of problems related to secret management, SAML, host management, things like that, permission management at our scale. These things are all homegrown. They work at our scale. They support our growth. So we don't want to reinvent the wheel when we go into AWS. We want our services to expand and support AWS naturally. An ideal state for us would be if our developers don't even know they're deploying stuff in cloud. It should look very similar to our internal infra. But this is a complex problem, right? Like, if you think about it, you always have this problem of selection problem to solve. I'll give you 2 examples. So internally, we use Chef to manage millions of machines. We have added a lot of features to Chef. We use it very heavily in our internal co-op and prod environment. When we go into AWS, AWS has competing native tools like SSM, OpsWork, and stuff like that. So if we go ahead and use OpsWork or SSM, we don't have to maintain the underlying infrastructure to do our host management. But also at the same time, it's hard to integrate something like SSM with our internal vulnerability management teams. We don't want that. So we went ahead. We operate everything in cloud VMs using Chef to make our machines look very similar to our co-op and prod environment. This helps us integrate cloud with other security teams in Facebook. There's another example, selection problem for security tools. We at Meta have created a lot of homegrown security tools for our infrastructure. They're very optimized for our scale. At the same time, AWS provides GuardDuty, config, things like that, which are very well integrated within AWS itself. They depend on VPC flow logs, DNS logs, and stuff like that. If we were to integrate our tools in AWS, it's a very hard challenge to solve. We decided to use GuardDuty here. So this selection problem is like a debate for everything we do internally in the team, and it's a good debate to have, in my opinion. So when you start your AWS journey, first step is to understand the requirements, the things you want to solve. What is your team? What is the end goal for your team? This can help you determine a roadmap, stay on track. This is where we start. So this is the AWS shared responsibility model. If you go through AWS documentation, this is the first thing you'll see. What does this diagram basically say? It says AWS is responsible for security of the cloud, and customers are responsible for security in the cloud. Expanding upon that, so AWS will make sure the applications, the services AWS has, the networking hardware, even the physical buildings are always protected. Nobody can come into an AWS data center and steal a hard drive. That's AWS responsibility, and they will make sure that does not happen. On the other hand, customers are responsible for encrypting their data. AWS will provide you encryption tools, but it's your responsibility to use those tools. Customer responsibility can change depending upon the type of tools you use. So if you're using an EC2 machine, you're responsible for your patching. You're responsible for firewall configuration. You're responsible for a lot of things. But if you're using something like S3, you're not really responsible for underlying operating system. You're not responsible for patching S3 for something like Log4j or something like that. Same with auditing. We at Meta are responsible for a lot of compliance things. So we go through multiple audits every year, multiple audits every half. So we are ourselves responsible to use AWS provided tools, AWS provided APIs to make sure we can collect the data we need to pass those audits. In Meta, this is the shared responsibility model we came up with. The Cloud Foundation team in Meta is the connecting tissue for the company and all the AWS users and AWS itself. We are responsible to make sure security alerting detection tool always work in every account, every part of infrastructure in cloud. We are responsible for the managed IAM tooling for everyone in cloud. We have built AMI pipelines. We have built container pipelines. We have built central repositories for all of these things. We also provide customers with building blocks, basically Terraform modules. If you need to create an S3 bucket, you want it to be secure by default, we provide you with a template. Use our template, use multiple templates we own, you can be sure your larger infrastructure will be secure by default. On the other hand, customers in Meta are responsible to use our provided tooling. If you use our tooling, a lot of these things will be done for you. You don't have to worry about short-term credentials. You don't have to worry about encrypting your data and stuff like that. A lot of these problems are taken care of if you use our tooling. If you're not using our tooling, we have policies. You need privacy exceptions. Those are not easy to get. So as a customer, as a cloud user in Meta, you have to use our tooling. And my team owns all these tools, and my team actually maintains all these tools. So we have expanded all these tools. So now you have a clear understanding of what you're supposed to do, what you're supposed to fix for your company, what's your role in the cloud journey for the company. Now you can actually start building a secure environment for your people, secure environment by default for your people. Building a secure environment starts with account provisioning itself. So when we provision an AWS account, we want to make sure we have visibility into the account actions. We want to make sure we have default security monitoring and alerting on that account. We want to make sure we have guardrails against things we don't want our users to do. So what do? Well, we use native AWS tools to achieve that. So CloudTrail provides us with all the actions going to AWS backend. What are those actions, who perform them, everything is provided in CloudTrail. Config Snapshots provides us with asset inventory. It provides us with configuration of all the resources in an account. It provides us with what type of resources they are, who created them, and we get the latest snapshots from all the accounts all the time. Config rules can evaluate if the configuration for a resource is up to standard or not. GuardDuty is the real-time threat detection system AWS has. It's an ML-based system. It's very integrated with the internal AWS technologies, internal AWS data sources. Macie is our PII detection framework. SCPs are service control policies. They let us block certain things we don't want people to do. We also use SCPs for other things, which I'll explain later in this slide deck. Manage IAM is our tool. It is a tool we provide for everyone in Meta to manage IAM. We don't want anyone to use console to manage IAM. That's one of the things we really enforce. Auth-D is our SSO solution. It's the federated role solution we built for Meta. Service level gating. So before I go into service level gating, let's discuss how an account is provisioned in Meta. So to get an AWS account, you have to go through multiple reviews. You have to file a request for that account. You have to go through legal reviews, privacy reviews, NetSec reviews. So when a team in Meta wants to use cloud, they have to request that account in our portal. We ask them a bunch of questions. Based on their answer, we trigger a bunch of reviews. These reviews are done by actual humans, so privacy reviews, legal reviews, policy reviews in general. Once you pass all those reviews, we can actually create your account. My team owns the automated tooling which creates those accounts, but you have to pass those reviews before we can actually create your account. One thing we do throughout this process is ask users which services they intend to use in their account. If a user wants to use S3 or if the user wants to use EC2, Dynamo, their risk landscape changes, right? Like the use case, the threat modeling for that account, the threat modeling for that use case is completely different from someone who just wants to use S3 than EC2 or something like that. So we collect that information. We will make sure you can only use S3 if you only requested for S3, if you're only approved for S3. If at any time you want to use additional services, you have to file additional request. You have to go through additional review process. This slows down our developers, but it also helps us implement privacy data deletion controls at scale. How does this work? We apply SCPs at account level. So if you have approval for additional services, our automated process will kick in. It will modify your SCP. It will allow you to use the additional requested service. This, as you can imagine, this can slow down the development lifecycle for the team. So in order to support our teams, in order to support faster development, we also allow people to use ephemeral accounts. So you can, in order to create an architecture, in order to figure out what you want to do in AWS, which services you want to do, you can request an ephemeral account from us. You can use it for a week or 2 weeks and decide on your architecture, decide on services you want to use, and then request your final cloud account. This is possible because AWS released a Clojure API in organizations in last 6 months, which has enabled us to do ephemeral accounts now. Infrastructure management. So one of the main tools we provide as a team is called Cloud CLI. It's a wrapper around Terraform. It has a lot of built-in integrations, integrations for SSO, integration for logging, a lot of different integrations. You can build your armies using Cloud CLI. It's a Terraform-based tool. We maintain that. We manage that for the company. We essentially want our infrastructure in code. Everything, every resource being created in cloud should be described in Terraform, should go through source control, should go through diff review process, PR review process, and once you have approvals, you're allowed to deploy that. What does that give us? That gives us a choking mechanism where we can actually do static code analysis on your code, static code analysis on your Terraform resources. What do I mean by that? We have created lint rules. So we see your code, we see the configuration you want for your resources, and based on that, we can generate alerts for that. If you, for example, if you request a P424X large instance, which can cost, I guess, $30,000 every hour, we don't want that for every use case. You probably don't want that for your use case. We will alert you about that in the code itself before you deploy that. If we see you're deploying an EC2 machine without a security group, we can warn you about that before it gets deployed. It's a very primary preventive control we have. This makes sure a lot of security problems don't end up in production. Secure building blocks, I think I spoke about this earlier, but these are basically small Terraform modules my team owns, my team provides. So if you want to create a larger infrastructure, you can use our modules to create individual resources. The configuration for these individual resources is secure by default. So if we want an S3 bucket to always be encrypted, using a KMS key, we enforce that in our module. You use our module, you will always be compliant. Same thing with security groups. If you want a Bastion host, you use our module. We manage the SSH keys for you. We manage the firewall configuration for you. A lot of these things are free. You just have to use our module. You just have to use our CLI, and all this is part of the framework. So role federation. Before I go deeper into role federation, let's discuss AWS IAM. In AWS IAM, there are three main entities: policy, user, and role. There are other things like root, user, groups, but let's ignore them for a second. So policies are nothing but a permission set. They are headless on their own. They are useless unless and until you attach that to a role or a user. IAM user, on the other hand, is an actual usable identity. So with IAM user, you get static credentials. You get permanent credentials. We don't want that. We don't want them in our infrastructure. We don't want them in production environment. We want everyone to use role federation because roles, IAM roles, only give you ephemeral credentials. They go away in some time, in a limited time. We don't have to worry about them leaking on GitHub. But with IAM users, that problem is always there. So this is how we solve role federation. There are multiple ways to solve this. There are multiple companies which can give you this tool. Okta, Ping Identity. Even AWS has a managed native AWS SSO service. But we built our own because we wanted our developers not to learn a new thing. We wanted them to still keep using the Meta-provided permission management system. So we built our own thing here. How does it work? We built an application called authd. So developers, services, machines can call our service. Our service will check against the internal Meta permission management system. If the internal permission management system says, yes, this person, this machine, this identity should be allowed on this account, we will call AWS STS service, generate a short-term token, and hand it over to the user. The user can use this token in code. The user can use this in console or CLI, whatever they want to. The biggest thing to remember here is we don't have to worry about static credentials here. These credentials will go away automatically. By default, we only allow these credentials for an hour. You can request up to 4 hours. If you need more than that, you have to come and talk to us and explain your use case. So with role federation, these are the two default roles we create in every account. One is admin, one is read-only. So admin you can use to deploy infrastructure in Terraform. Read-only if you just want to do, if you want to just see console and see the configuration of your resources, don't want to do any write changes. Like I said earlier, by default, 1 hour, credential will go away after an hour. This is a control I recommend everyone to do. We do all this via SAML. So we put a public SAML cert in your account. We own the private cert. Whenever you want to access an account, we will sign that request with our private cert. AWS will be able to verify that using the public cert, and that's how all this works. We protect our SAML resources in your account using SCPs. Nobody can modify them. Nobody can touch them. Nobody can steal your session. So overly permissive IAM is a massive problem in AWS. So imagine a use case where you as a developer are working on an application and you have to interact with different AWS services, like your EC2 machine is talking to Dynamo, S3, a lot of different services. To fasten your development life cycle, you may end up creating an admin role and attaching it with your EC2 instance. That can really fasten your development lifecycle. You don't have to worry about permission all the time. You can just do whatever you want in your account. But that's a nightmare scenario too. If a 0-day happens and your EC2 machine is taken over, then the malicious actor has control over all of your account. We don't want that to happen. We don't want to deal with that. So we created a managed IAM solution for users. We want IAM to be source controlled. We created a native service for it. So you write code, and our service will deploy that permission set in your account. So users cannot create IAM resources without going through source control. We can actually control things like, if we see you attaching action star, resource star with a permission set and attaching it with an EC2, we can create a warning for you in code before it gets deployed. The idea here is we want you to think about permissions. We don't want you to just attach admin everywhere and get your job done. Custom roles are the only way to make SSO work in Meta. There's no other way you can make an SSOable role in Meta. You have to go through our tooling, you have to go through code review process, and that's all we want here. We call it manage IAM, but essentially it picks up the config you publish in code, it deploys that in your account, and that's essentially what it does. So now you know what responsibilities you have. Now you also know, now you have already created a bunch of baseline security services. The next step of the process is enforcement of security policies, enforcement of all these tools, forcing users to use all this. To do that, the first step is to create a security monitoring, detection, and alerting system. These are the requirements we came up with for this system. We wanted it to be scalable. As we increase our AWS footprint, as we add more accounts in AWS, we wanted our system to scale. We wanted long-term support here. We are just one single team doing all this work for Meta. We don't want to own the long-term support for this kind of system. We want it to be flexible. There are very unique use cases that run in AWS for Meta. They're not all same. They're all very different from each other. So whatever system we built, it needs to be flexible for our end user, for our customers, for our product owners. We want this system to integrate well with internal AWS provided technologies, data sources, and stuff like that. So this is the high-level design of our system, how it works. We wrote a tool called Cloud Admin. It goes in every account. It sets up all these services in every region of an account. We chose GuardDuty, Config, Macie, CloudTrail. We set up these services in every region, in every account. We aggregate the logs for all these services, collect these logs, bring them back to Meta. Once they are in Meta, we are based on our configuration for alerting. users will get notified in case we notice any event on their resources. In case we notice an SSH brute force, they will get an immediate alert. Users are forced to respond to these alerts by policy. If they don't do that, we can take certain actions. So why these services? So GuardUI is the most important real-time threat detection native service in cloud, in AWS. It provides us with network level events, anomaly detection, things like that. Config helps us do checks against the configuration of a resource. So we can check if your EC2 is configured the way we want it to be configured. Macie is for PII detection. If we see you accidentally uploading anything related to user data or something like that, we can use Macie, detect that, alert you on that. CloudTrail comes handy because it has all the events in your account which are going to AWS backend. We can do a lot with CloudTrail, and we try to do that. So event handling. Before I go deeper in here, let's discuss organizational units. So because we collect all the information before an account is created, the use case, the kind of data you're going to use, the network architecture you have, we are able to organize accounts into OUs. OUs are nothing more than organizational units where you can aggregate accounts and administrate them together. Different OUs have different uses. For example, if you don't want to create an IGW, Internet Gateway in your account, we will push your account to a specific OU where you can't do that. If you want specific privacy policies on your account, tagging policies on your account, we will push your account to a specific OU where you have to do all that. At Meta, we have multiple organizations due to legal and compliance reasons. We don't only have one single organization. We have multiple organizations. We manage all of these organizations in AWS. All of our accounts are placed in different OUs based on their use cases. So in case, we have a special OU called Cloud Jail. It's essentially where we block every API call to AWS backend. We cut off all the existing network in that account. So in case we notice a real-time threat, in case we see an EC2 gets taken over mining Bitcoins or something like that, we move the account to Cloud Jail. We make sure the malicious actor cannot do any more harm. That's our primary, once the account is in jail, our other security teams can come in, do the investigation, take snapshots, do whatever they want, but we make sure malicious actor cannot do much harm from that point. This is very important. We have automated this end-to-end. One of our admins can do, move the account to jail, and that's it. We have built other tools for post-investigation too. We can do encrypted EBS snapshots. We can do other kind of data analysis, but this is one of our primary controls. If we see you as a product owner not responding to our security alerts, we can also push you to Cloud Jail in that case. If you're not complying with policy, we have this option. This is very handy, and we have used it a lot in past. Validation checks. So now you have done, you know your responsibilities. You have a secure baseline for all the accounts. You also have enforcement mechanism. You also have detection, security alerting. Now we want to make sure everything is working as intended. So for that, we do validation. How does it work? Regular audits. So we do manual regular audits every 6 months on every use case. We have a team of privacy program managers who go and ask every account owner their current use case, their current usage. We want to learn if there were any changes in your existing use case, in your existing account. We want to make sure we know about those. We want to make sure we can, if something has changed, you should comply with additional policy controls or something like that. This also gives the users a chance. If they want additional services, they can speak to our privacy program managers, get their approvals, and we can enable those additional services for them. Regular auditors are also responsible to make sure our account owners are responding to our security alerts. In case they are not responding to our security alerts, this is the time where auditors can take action on such accounts. AWS health notifications. So health notifications at organization level are a major part of our validation framework. They provide us with a lot of scheduled changes or operational things from AWS. We use them at organizational level. We collect all this information for all the accounts, and we use it to validate if the privacy controls we have built, if the security controls we have built are working as intended. Drift detection with Terraform. So if you've used Terraform, you know the way Terraform works, it has a state file. So every resource Terraform is managing, every resource Terraform is creating, a state file is recording all the configuration for those resources. State file is the source of truth for what Terraform is managing in your account. What we have done with that, we built an internal system which keeps running your Terraform on your account in plan mode again and again. So in case we notice a drift, in case we notice a change outside the Terraform configuration, we want to send you an alert. This happens all the time. Someone will go in console, make some changes. We don't want that to happen. If that happens, we can alert you immediately about that. This is an awesome way to detect drift in your actual drift between your code and your infrastructure. This is fully integrated with our CI/CD pipelines, and we reach out to customers in case we notice something like this. AWS config snapshots are used to do regular asset inventory in our infrastructure. We use these things to take regular snapshots, regular configuration for your account, and we want to make sure you're complying with all the policy controls we want you to comply with. Config rules are awesome. In the slide earlier, I talked about Terraform lints and static code analysis. That only gives you preventive control. So you can prepare a lint rule, you can do static code analysis and stop bad things from happening going in production. But what if you were too late in creating your lint? What if the vulnerable configuration is already on an account in production? For that, we use config. So using config, you can compare the configuration for a resource and compare it against the configuration you want on that resource. You can do this for existing resources. So this gives us, like, if right now I figure out, oh, we need to encrypt all our S3 buckets, but in the past we were not doing that. Config rules will help us to determine which resources we want to update. We do various different checks with config, like ACM certificate expiration, if we see an API gateway without logging, and things like that. We can do a lot with AWS config rules, and we use them heavily. And you can also do custom rules, custom config code to detect changes, to validate your policies. That is all for the Meta's AWS journey. You can reach out to me or Tim after the talk, or if you have any questions, please go ahead.
I'd like to add that you can get a copy of this video out on AWS Events YouTube station in 1 to 3 days, and you can download a PDF of this entire deck in about 1 to 2 weeks, also from the AWS Events page. Questions?
You mentioned about CloudJail and how you use the entire account. How do you mitigate customer impact if you're doing that to the entire account?
That's a good question. So the question is about CloudJail and how do we mitigate customer impact of doing such an action. So we don't do this for every alert, every threat. We do this for validated persistent attacks or something like that. If we are sure an attacker, malicious actor is able to, is doing actual harm in an account, only then this action is taken. If we are sure the account owners or the product owners are not responding to a security alert and not complying with our existing policies, only then this action is taken. We don't do this very lightly. We don't ever want to do this, but we end up doing this sometimes.
Earlier on, you mentioned in the threat modeling stage, you enter a questionnaire, it's a very manual process. Any thoughts about making that less manual in the future? Question mark.
So it used to be not that manual, but then we started to make it manual. But then we started to add in more and more policies in our AWS usage. So we have created a portal. We have like a completely automated workflow kind of portal where users can request all these things. We have provided them with default answers and stuff like that. It is a lot of manual because it's a lot of humans are involved in this process. You have to go through multiple reviews, and we try to automate it, but still, you need a legal review, you need a privacy review, you need a NetSec review before you start your AWS journey in Meta.
Are you using AWS mainly for just your workloads? Because I've noticed like kind of with the SCP that you had to play multiple orgs, specific enabled, and even affecting the customer. I would think that you're just using it for your developer backend, and you're not like facing like web servers or anything in there. So like, are you guys just using it for that?
So you want to know if we are using our AWS workloads just for the backend services. So we have a lot of AWS accounts, and all of these are doing different things. I can't really go into detail about your use cases in cloud, but we are using it for all kinds of things. Some people are running GPU workloads. Some people are doing API level development. Some people are doing data sharing with third parties and stuff like that. So we have unique use cases in all these accounts. It's not just for one single backend-y application. It's a lot of different applications.
And then part of that is you mentioned you have multiple orgs, and are you segmenting those orgs based on the use case?
So multiple orgs, why do we have that? That's the question. There are legal reasons. Meta has to comply, which is the reason why we have multiple orgs. Ideally, we should all have one single org in AWS, and we should be trying to manage that. But due to various different legal reasons, we have to comply in different regions of the world. We have multiple orgs, and we have to manage all that.
So in your last slide, you mentioned cloud infrastructure validation. So where is your infrastructure policy defined and enforced? So question is, in Terraform, Meta, or AWS?
So you want to know where our policies are defined and enforced. So where our policies are defined and enforced. So I would say we do multi-level enforcement. So we have preventive controls using Terraform. We have controls like vulnerable config detection using config. So we want this security process to be baked in throughout the account lifecycle. So from start, when you request an account, we want to evaluate if your use case is secure enough to run in AWS. Once you are using cloud, we want you to make sure you are using Cloud CLI, Terraform code. There we can do static code analysis on your infrastructure. Once your infrastructure is up and running, we activate services, native AWS services, and we do threat detection, monitoring, alerting based on that. So it's all baked in every step of the process. There's no like one single location where we are applying all of our policies. It's throughout the process. So where are the centralized policies defined? Like, so it's the policies are defined in Meta internal policy framework, but they are enforced by us at different points in the account lifecycle.
Just exploring the separation of responsibilities that you talked about throughout. You talked about scanning the infrastructure. You talked about AWS's responsibilities. The code that's deployed itself, what interaction, if any, does your team have with, kind of the static analysis, the open source governance, whatever those teams are doing prior to bringing that code into the environment?
So you want to know the application code running in AWS, how does my team what's the involvement about scanning and stuff like that. So we provide engineers in Meta all these tools to integrate with our internal CI/CD pipelines. So we take care of your, Cloud CLI will enforce infrastructure level policies in your Terraform code, but the application code itself, it goes through the internal Meta scanning, code scanning processes. Like as a customer, you're supposed to write secure application code and only worry about that. That's our dream state. Like if you write your secure code, we make sure your infrastructure is secure, and that gives us end-to-end security. So we have internal Meta resources doing the scanning, static code analysis, and other things in Meta code base, and that's what we use for AWS code too.
But there's no like policy coming from your team into the teams that are writing that. They just get into the standard tools.
Yeah, so if you're using standard Meta CI/CD pipelines, you get that all that for free. Yeah. Yes.
For Amazon AC, you said that once or identify user data from over between the accounts. For that, I assume that people might use anonymized data to do some use case testing. How do you use Macy to see the difference between them? Because statically anonymized data might look the same in metrics on the production data or anonymized data.
So you want to know about how we deal with anonymized data in Macy, how we false alarms basically. So our tooling is pretty flexible for each user. So whatever alert we send to a cloud user, they have the capability to suppress those alerts, accept the risk. They verify themselves. Yeah, yeah, yeah.
And then, when PII in the US is defined very different than personal data globally,
Yeah.
and you say user data that globally encompasses any sort of metadata associated with that user, how do you kind of define personal data really within Macy to trigger that order? I assume that they're kind of global rules set up and it's hard to
So you want to know about how we deal with different PII standards all around the world in Macy. So in Facebook, we have internal teams who define what is PII. So based on that policies, we have a globalized set of things we want to detect using Macy. Yeah, we have a full team dedicated to defining what are we complying to PII standards all around the world. So we use them to come up with those policies.
You mentioned you use SCPs based on the use case that something was going on. How granular do you get with SCPs?
So how granular can we get with our SCPs? So we have SCPs at every level of the tree structure in organization. We have multiple OUs. So all those SCPs, like if 5 accounts are part of a single OU, they get all that SCPs. But for service level gating, we even do account level SCPs. So at your account level, we can activate, deactivate certain services for you, and things like that. So we can get very granular. Our automated tooling understands all that. We have a policy generation framework which manages all that.
When the customer asks for a new account, do they know what they need?
So when customer asks for a new account, do they know what they need? So not really. That's a problem. We try to help our customers do that using ephemeral accounts. So before you finalize your architecture, you can use our ephemeral accounts, figure out what services you'll end up using. Then you can request for those services based on your requested services, your risk assessment, your threat modeling, all that will change, and our SCP generator will attach that recommended policy on your account.
I have 2 questions. So the first one is about your technology choice of infrastructure flow. Just wondering, choose Terraform and AWS CDK, all I have thoughts about between them. And the second question about how do you control access to the PI information, for example, Facebook Meta. In general, for example, how do you prevent data from exfiltrating to outside, someone accessing that file or reading information that it's not supposed to read? How do you control that?
Okay, so the first question is, how do we control data?
The first one's more technology choice, infrastructure as code, Terraform versus CDK.
Okay, the first question is related to why not CloudFormation, why Terraform? Yeah.
Terraform is a little bit lower layer,
Okay, Terraform is open source, right? Like Terraform, you can do a bunch of things in Terraform, which we have added our own integrations. We have our own Facebook provider for Terraform internally, which is also hooked up with our other internal services. So Terraform allows us with that flexibility. Other CDKs generally don't are not that open sourced. So in Terraform, we can create our own FP provider. So the way Terraform works, it has AWS provider, it has other cloud providers too. AWS maintains AWS provider. We maintain the FP provider internally, my team, and we have added a lot of integrations for internal tools in Terraform. So Terraform was the obvious choice because it's just like easy to, And the second question is how we maintain PII access internally in Facebook. How do we make sure people who should only have access to this table or something like that? Yeah. So this is more of a question for like how Meta does permission management internally. We have systems, we have internal systems which allow people to create ACLs on every table, every data resource internally. So if you want to read a table, you need to be on that ACL. If you are, so other is if you have access, how do we make sure you're not egressing all that data out, right? So we have a team dedicated to do that. It's called Data Out. They keep an eye on all the traffic coming in, going out from our internal infra. And if they observe something like that, if they observe you can actually, depending upon the pattern of exfiltration, you can actually detect stuff like that. We have a dedicated team which is doing that. It's not my team.
So you mentioned using Macy for PII detection, right? So in terms of the discovery tables that Macy provides, you have a lot of custom classifiers being provided by the customers, but it's not very comprehensive, right? Do you just use Macy, or do you have some additional discovery tool?
So the question is, do we just use Macy, and or do we have other tools? So internally in Meta, we have different PII detection tools. I think Meta has invested a lot of energy to make sure PII is very well compartmentalized, not exposed to the outside world. So internally, we have other tools. But in AWS, we use Macy. We are trying to build other interactions with internal tools, but for now, it's just Macy.
And one additional question to that. So is it just for discovery? Once you discover an analyst, right?
Yeah.
Exactly. Or do you do some enforcement, like detect, tokenize it? Do you have some sort of enforcement?
So what's the enforcement mechanism once we discover PII in an S3 bucket? So policies are, so we send an alert, and when we send an alert to you, by policy, you have to take an action on it. If you don't take an action, you violate the policy. That's our enforcement mechanism here.
So it's not an auto behavior, it's more of a workflow. You just have to
Yeah, you have to go through the exceptional workflow, and it's very hard to get that exception.
Time for a few more questions before we have to leave the room, sir.
So you kind of mentioned before, again, earlier in the design phase, hey, if I pick what services I want to use, I review, but later if you decide something else, got to re-review again. Is there something where you're like, you'd say, this is the standard way to use S3, and if you do it in this standard way, review is super easy compared to like some of your custom implementation?
So you want to know?
Is there a paved path
Is,
for services?
okay, so you want to know is there a paved path to get approval for additional services or something like that?
Additional services are just things that have already been used by other people.
So there's no paved path for every service. But for some standard use cases, like, I don't want to have any outside network connections. I just want an EC2 machine close to the world. Yeah, that makes your review easy. We have that in the workflow. But we don't have that for every use case. There are just more than, I guess, 200, 300 services in AWS. It's very hard for us to do that for every service.
Okay.
Yeah. Yes.
I saw one of your Terraform checks were for open security groups submitting from the internet. Do you usually never allow that, or do you have exceptions for things like public load balancers or
So you want to know if our security group check, if we ever allow people to do that or not. So we do that for things like load balancers. Sometimes you need EC2 resource which is open to the world to serve web traffic or do other things. So we do allow that, but we will detect that in code. We will alert you about that. We want it to be very, we want you to make sure you need that before you actually deploy that. We want people to think about it before they do something like that. Yes.
How do you address like scalability issues and like maintaining like embedded security controls in these resource templates and your like policy checks and stuff like that, especially with AWS like releasing new features and new services like every day?
So how do we maintain the scalability with AWS releasing new features and
They can become deprecated quickly if it doesn't have a particular feature that just got published the other day or something.
So that's a good question, and that was like a debate within, should we create our own services? That's why, in my opinion, we ended up using GuardDuty, using AWS Priority Tooling, because AWS maintains it for us. We just integrate those things with our internal tools. So once a new type of threat shows up in GuardDuty, AWS will add that. We'll automatically start ingesting that. We don't have to like update our system or something like that.
So you use like new alerts coming out of like the embedded like SecOps tooling to inform you when like new policies or new resource templates need to be created or updated?
So policy update. So how do we do policy updates? Policy updates are done by a different team. It's a privacy program policy team. They do look at policies every 6 months or something like that at regular cadence. And if they deem something outdated or something like that, they manage the update part. My team is an engineering team, so we manage the engineering behind the scenes.
And apologies, I meant infrastructure as code checks and policies code.
Oh, okay. So infrastructure as code, they are dictated by our policies. So if we don't want anyone to use a certain type of EC2 machine, we block that in Terraform. Yes. So our tools and policies FedRAMP approved. I'm not sure about that. So what do you mean by FedRAMP approved? Oh. Can you use the Meta products when you're dealing with federal customers? My answer is probably no, because these all are custom tools we built for Meta itself. They're not supposed to be used by any AWS customer, just for our internal use cases and very, very tightly integrated with our internal technologies. So in my opinion, it won't be easy to use them outside Meta.
We have time for one more question, but Akansh said he's willing to step out in the hall and answer other questions if you have them. Over here, sir.
So how do we do drift detection? So we use Terraform. The way Terraform works, it creates a state file. We own that state file. We can read it anytime we want. We can make changes to it if we want to. So state file basically has all the resources configured in your account via Terraform, the configuration for all those resources configured via Terraform. It has like hashing mechanism to track the current configuration and state of those resources. So the way our drift detection work is our Cloud CLI tool will keep running your Terraform code in plan mode against your account. If we notice any changes to the infrastructure, if Terraform says, oh, I don't recognize this resource or something has changed outside Terraform, Terraform is good like that. We can detect that. We can alert you that something has modified outside your code. So that's how we do drift detection. You can do drift detection using CloudFormation too, but we chose Terraform, so we do it by Terraform.
Thanks for coming. Like I mentioned, Akansh is willing to answer a few more questions out in the hall. Give us a couple minutes to get out there. Enjoy the rest of Reinforce.